Good evening, everybody. My name is Ferhan Mazher, and in this video, we are working on the solution of the course book of the Pure Maths 1. For this purpose, in this video, we are working on the exercise 5F, and this is our 10th episode on this exercise. In this video, we have started our work from the question number 9. It's a G part. The topic of this exercise is trigonometric equations, and the question which is given to us, let me show you that. Exercise 5F, and we are working on its question number 9, and it's a G part. So we are working on the G part. 2 cos square x minus sine square x minus 2 sine x minus 1 equals to 0. So solve each of these equations for x equals to 0 and greater than 0 and equals to and less than 360. So this is the question I am going to attempt. I have already solved it to save the time. So you can see here that they have given us this. 2 cos square x minus sine square x minus 2 sine x minus 1 equals to 0. So in the place of the cos square x, I can substitute from the first identity. Cos square x can be written as 1 minus sine square x. So I substituted this cos square x with 1 minus sine square x. So this 2 is multiplying, so it will become 2 minus 2 sine square x minus sine square x minus 2 sine x minus 1 equals 0. So you see what I have tried to do. I have tried to make this whole trigonometric equation in the same trigonometric ratio. Okay, so 2 minus 2 sine square x minus sine square x, this will become minus 3 sine square x. And this is minus 2 sine square x and plus 2 and minus 1, so plus 1 and equals to 0. So multiply both the sides with the negative. So when you multiply both the sides with the negative, the signs will change. This will become plus 3 sine square x plus 2 sine x minus 1 equals to 0. Then you see, treat it like a quadratic equation. And here I'm going to do the midterm breaking. So the two factors are 3 sine x minus 3 sine x. So 3 sine square x plus 3 sine x minus 1 equals to 0. From the first two terms, you can take 3 sine x common. So you are left with the sine x plus 1. And from the last two terms, you can take minus 1 common. So in the bracket, you have sine x plus 1. So from this term and this term, I can take this bracket common, which is the sine x plus 1. And in the other bracket, I will have 3 sine x minus 1. These two brackets, they are multiplying with each other, and their answer is 0. So what I will do, I will make these brackets 1 by 1 equals to 0. So you will have sine x plus 1 equals to 0. You see here, sine x plus 1 equals to 0. So sine x will be equals to minus 1, and x will be equals to the sine inverse of the minus 1. And so the x, where is the sign negative 1? It is on the 270. Okay, so the other thing is 3 sine x minus 1 equals to 0. So sine x will be equals to 1 by 3. X will be equals to the sine inverse of the 1 by 3. So when you take the sine inverse of the 1 by 3, you get 19.5 degrees. Okay, so that's your base angle. You know, this is positive. Sine is positive into quadrants. It is in the first quadrant and the second quadrant that the sine is positive. So this is the 19.5 is the base angle. So the angle which will be in the first quadrant, that it will be equal to the base angle, that is 19.5. The angle in the second quadrant is equals to the 180 minus the base angle. 180 minus 19.5. So you will get 160.5 degrees. So the answers are three. One is 19.5, the other one is 160.5, the other one is 270 degree. So let me check, sir. This is the question number 9, and this G part exercise is the 5F. We are working on the question number 9. It's G part. Yes, the answer is right. Let me show you the answer, sir. The question number 9, and its G part, 19.5, 160.5, 270. So our answer is right, sir. So this is how you will do the question number 9. It's G part of the exercise 5F from the course book of the Pure Maths 1. This syllabus content is related with the Cambridge International AS A-Levels Mathematics 9709. So, my dear students, now we are on the question number 9. It's H part. Let me show show you the question. Question number 9. Its H part is showing up on your screen. It's 1 plus tan x cos x equals to 2 cos square x, and we have to solve each of these equations for x greater than or equals to 0 and less than and equals to 360. So H part we are going to work on it, sir. So you can see uh, what we will do. In the place of this tan x, I substituted sin x by cos x. And in the place of cos square x, I substituted 1 minus sin square x. Okay. Cos x will be cancelled. So you will have 1 plus sin x equals to, this will become 2 minus 2 sin square x. Okay. So take this to the other side. So 2 sin square x plus sin x plus 1. This will become minus 2 equals to 0. So you will have 2 sin square x plus sin x minus 1 equals to 0. Treat it like a quadratic equation, and we will solve it with the help of the factorization. So I'm going to apply the midterm breaking here. So the two pairs, the two factors will be 2 and minus 1. So 2 sine square x plus 2 sine x minus 1 is equal to 0. I've done the midterm breaking. From the first two terms, you can take 2 sine x common. So you are left with the sine x plus 1. From the last two terms, you can take minus 1 common. So you are left with the sine x plus 1 in the other bracket equals 0. So in this expression and this term, I can take this sine x plus 1 bracket common. So in the other bracket, I'm left with the 2 sine x minus 1. So these two brackets, they are multiplying with each other. Their answer is 0. The product is 0. So that means that both the brackets can be made equals to 0. So sine x plus 1 equals to 0. Sine x will be equals to minus 1. X will be equal to the sine inverse of the minus 1. And you know the sine inverse of the minus 1 is 270 degree. The other pair is, the other bracket is 2 sine x minus 1 and equals to 0. So sine x will be equals to 1 by 2. So x will be equal to the sine inverse of the 1 by 2. So the base angle will be 30 degree. So then I will draw this my grid, and because the sign is positive, you can see here the sign is positive. So the sign is positive in the first quadrant and in the second quadrant, and the base angle is 30 degree. So the base angle is 30. Okay, in the first quadrant the angle is equals to the base angle, and in the second quadrant the angle is 180 minus the base angle. So it will be 180 minus 30, that is 150. So my answers are 30, 150 and 270. So this is how you will solve this. So this is how, and this is the question number 9. It's H part. This is how this is done. Let me just show you the answers. Question number 5. So the exercise 5 F, and we have done the question number 9, and it's H part. Let me show you the answer. So question number 9 and its H part. So you can see 30 comma 150 comma 270, and this is our answer, sir. And you can see that this is how this is done. Question number 2, H part. I hope that you understand this question, how this is done. Okay, so now my dear students, now we are working on the question number 10 and its A part. Okay, solve each of these equations from for the x equals to and greater than 0 and less than and equals to 2 pi. A part is 4 tan x equals to 3 cos x. So this is the question number 10. I'm going to work on its A part. And you see here we have the x values from 0 to 2 pi. Okay, 4 tan x is equals to 3 cos x. In the place of the tan x, I will substitute it with the sin x by cos x. So 4 sin x by cos x equals to 3 cos x. This cos x will come here and it multiply with this cos x, and so this will become cos square x. So 4 sin x equals to 3 cos square x. 4 sin x equals to 3. In the place of cos square x, I will write 1 minus sin square x. So you will have 4 sin x equals to 3 minus 3 sin square x. Take these two terms to the other side of the equal. So you will have 3 sine square x plus 4 sine x minus 3 equals to 0. So because its factors are not possible, its midterm breaking is not possible. So what I will do, I will apply the quadratic formula. So the sine x will be equals to the minus b plus minus under root b square minus 4ac divided by 2a. So you will have sine x equals to minus 4 plus minus under root, and under the radical we have 4 square minus 4 into 3 into minus 3 and divided by 2 into 3. So you will have minus 4 plus minus, this is 16 plus 36 by 6. Okay, 16 plus 36, that's 52 under root 52 and divided by 6. So here we have two options. On your calculator you can do that. Minus 4 plus under root 52 equals to divided by 6 equals to, it will give you 0.535. So sin x is equal to 0.535. So x will be equal to the sine inverse of 0.535, and your calculator must be set in radians because this is in radians. So please set your calculator, change your calculator from degrees into the radians. So then take the sine inverse, you will get 0.565. This is my base angle. So I will draw this diagram. So my base angle is 0.565 because this sine is positive. So it's in the first quadrant and in the second quadrant. In the first quadrant, the angle is equal to the base angle, so it will be 0.565 radians. In the second quadrant, the angle is pi minus the base angle, so it will be pi minus 0.565. That will give you 2.58 radians. So the x will be equals to 0.565 radians, comma 2.58 radians. The other thing is that you will make sin x is equals to minus 4 minus under root 52 equals to divided by 6 equals to, that give you sin x is equals to minus 1.8685. So you do sine inverse of the minus 1.8685 because this value is greater than 1, so its sine inverse is not possible. So that's not possible, sir. So your answer will be 0.565 comma 2.58. Let me show you the answers, sir. So our answers are right. I have already checked it. So let me show you. Question number 5. Sorry, exercise 5. And it's F part. Exercise 5F. Question number 10. And here we have the answer, sir. Question number 10A part, 0.565 comma 2.58 is the answer, sir. So you can see that our answers are right, sir. This is how you will do the question number 10 and its A part. We are solving exercise 5F. This is our 10th episode on this exercise. Actually, we are solving the course book of the Pure Maths 1. The topic of this exercise is trigonometric equations. The topic of this chapter is trigonometry. This is paper 1 of the Cambridge International AS A-Levels Mathematics 9709. My name is Ferhan Mazher. I hope you understand this question. So my dear students, now we will solve question number 10. It's B part. Solve each of these equations for x greater than or equals to 0 and less than or equals to 2 pi. So the B part is 2 cos square x plus 5 sin x plus 4. So the question number 10 is B part. Okay, so as you can see, we have already solved this. So 2 cos square x plus 5 sin x equals to 4. In the place of the cos square x from the first identity, I will substitute cos square x with 1 minus sine square x. So you will have 2 minus 2 sine square x plus 5 sine x equals to 4. So you are left with the minus 2 sine square x plus 5 sine x plus 2 minus 4 equals to 0. So it will be minus 2 sine square x plus 5 sine x minus 2 equals to 0. So multiply both the sides with the negative 1. So you will have 2 sine square x minus sine x minus 5 sine x plus 2 equals to 0. 2 sine square x minus 4, we will consider this as a quadratic equation, and we will solve it by the midterm breaking. Okay, I'm going to do the factorization by the midterm breaking. So 2 sine square x minus 4 sine x minus sine x plus 2 equal to 0. I've done the midterm breaking. So from the first two terms, I will take the 2 sine x common. So in the bracket, I will have sine x minus 2. From the last two terms, I will take minus 1 common. So you will have in the bracket sine x minus 2. From this and this term, I will take this bracket sine x minus 2 common. And in the other bracket, you will have 2 sine x minus 1 bracket close equals to 0. So these two brackets are multiplying, their product is 0. So that means I will make the first bracket 0, then I will make the second bracket 0. Okay. So sine x minus 2 equals to 0, sine x will be equals to 2. So x will be equal to sine inverse of the 2, which is not possible. Sine inverse of 1 and less than 1 is possible, but the sine inverse of 2 is not possible. You can check on your calculator. So it's not possible. So the second bracket, 2 sine x minus 1 equals 0. Sine x will be equals to 1 by 2. X will be equal to sine inverse of the 1 by 2. Do you remember this table? This is a very basic and famous table. So when I take the sine inverse of the 1 by 2, it will be pi by 6. You can do this on the calculator as well, but because of the answer, I draw that table. So sine inverse of the 1 by 2 will be equal to the pi by 6 radians. So the base angle is pi by 6 radians. Then I will draw this grid. So because this is sine is positive, so the sine is positive in the first quadrant and in the second quadrant. My base angle is pi by 6. So on both the sides, I will draw this. So in the first quadrant, the angle is equal to the base angle. So the angle in the first quadrant will be equal to pi by 6. The angle in the second quadrant is equal to the pi minus the base angle. So it will be pi minus pi by 6. So that will be 5 pi by 6. So the x is equal to pi by 6 and 5 pi by 6. So these are my answers. Let me show you the answers for the question number 10 and its B part. So here we go. Question number 10 is B part, pi by 6 comma 5 pi by 6. So this is how you will do the question number 10 and its B part. And I hope that you understand that how this question is done. And this is the question number 10B part from the exercise 5F of the course book of the Pure Maths 1. This is our 10th episode on this exercise. The topic of the exercise is the trigonometric equations, and the topic of the chapter is trigonometry. This is the syllabus content of the this is the syllabus content of the Cambridge International AS A-Levels Mathematics 9709. My name is Ferhan Mazher. So, my dear students, now we are working on the question number 11 of the exercise 5F, and it's the last question of this exercise. And this is our 10th episode on this exercise. Let me show you the question. The question number 11. Solve sine square x plus 3 sine x cos x plus 2 cos square x is equal to 0. The x is from 0 to 2 pi. Okay. So let me show you how this is done. And so sine square x plus 3 sine x cos x plus 2 cos square x equals to 0. The x answer is from 0 to 2 pi. Okay. So I will consider this as a quadratic equation, and I will do the midterm breaking. So I will have sine square x plus 2 sine x cos x plus sine x cos x plus 2 cos square x equals 0. So I've done the midterm breaking. I'm going to do the factorization. So from these first two terms, I am going to take the sine x common. So you are left with the sine x plus 2 cos x. From the last two terms, I'm going to take the cos x common. So I'm left with the sine x plus 2 cos x. So from this term and this term, you can take this bracket sine x plus 2 cos x common. So you are in the other bracket, you will have sine x plus cos x. So these two brackets, they are multiplying, their product is 0. That means either the first bracket is 0 or the second bracket is 0, or both of them are equals to 0. So I will make the first bracket equals to 0. So sine x plus 2 cos x equals to 0. So that will be equal to sine x equals to minus 2 cos x. Divide both the sides with the cos x. So you will have sine x by cos x equals to minus 2. So the tan x will be equals to minus 2. So x will be equals to the tan inverse of the minus 2. Forget the minus 2, just take sine inverse of the 2. You will get 1.11 radian. Your calculator must be set in the radians. So this is the base angle, 1.1 radian. So I will draw this diagram, okay? The tan is negative. The tan is negative in the second quadrant and in the fourth quadrant. So the base angle is 1.11, 1.11 here. The angle in the second quadrant is pi minus the base angle. So it will be pi minus 1.11. Use your calculator, it will be 2.03 radians. The angle in the fourth quadrant is 2 pi minus the base angle. So it will be 2 pi minus 1.11. That will be equals to 5.17. So these are the two answers. Then the other bracket and the other sine x plus cos x equals 0. So sine x is equals to minus cos x. Divide both the sides with the cos x. So you will have sine x by cos x equals to minus 1. And that will be tan x equals to minus 1. So x will be equals to tan inverse of the minus 1. So use this table. In the last question, when I used this table by mistake, I wrote here pi by 2. This is not pi by 2, this is pi by 4. It's actually 45 degrees in the radians. It is pi by 4. Just correct that mistake. In the question number, last question, when I draw that table, I use the same table, but by mistake I wrote here pi by 2. This is actually pi by 4. This is pi by 6, pi by 4, pi by 3. Okay. So the tan inverse of the pi, the tan inverse of the minus 1, tan inverse of the 1 will be pi by 4. I'm just taking the base angle. Just forget this negative, okay? So the base angle is pi by 4. So draw this diagram. The tan is negative. So the tan is negative in the second quadrant and in the fourth quadrant. So in the second quadrant, the angle will be pi minus pi minus the base angle. That is pi minus pi by 4. That will give you 3 pi by 4. So we got this. The angle in the fourth quadrant is 2 pi minus the base angle, 2 pi minus the pi by 4, and that will be 7 pi by 4. So my answers are 2.03, 5.17, 3 pi by 4, and 7 pi by 4. Let me show you the answers, sir. Exercise 5F, and we are on the last question, and the last question of this exercise is the question number 11, and the answers are showing up in front of you. Our answers are right. So I hope you understand this. So we are basically following this course book, sir. So this is the course book which we are following. All the questions and all the exercise are their property. This book is their property. This is published by the Cambridge University Press. Yes, this book is their property. Credit goes to them. So I hope you understand this question. It's a little technical, and I have tried my best to write the solutions in such a way and to describe them in such a way that you can understand them. So this was exercise 5F. This is our 10th episode, and we have completed this exercise 5F. We have done 10 videos on this exercise. I hope that these videos will be helpful to you. If you find these videos helpful, please like these videos. Also subscribe my channel. Please share the link of these videos with those people for whom these videos can be helpful, those students, those teachers who are preparing for the AS mathematics. So uh, I think that I have already told you many times that the purpose of these videos is to provide the help for those students whose basic mathematical skills are little weak. So they need this step by step guidance. The students who are very, very brilliant and they don't need this step by step guidance. So I hope that this video will be helpful for those students whose mathematics skills are a little weak. So thank you very much everyone for watching my video. And you know, your support, your comments, your likes, your shares, they are very, very important for me. And so please keep sharing this, please liking this video. So thank you very much everyone. Have a good night, sir. God bless you all.